Hi folks, 2015 questions here, so we'll kick off. So first thing we've been asked to do is finish out this orthographic here. So if we just want to call it 1, 2, 3, and 4. So it's been kind of nice. They've shown us, given us a hint already of how to do this. If you had forgotten, so you're bringing up your points parallel to the horizontal line. Then we're going to bring them up vertically, hit the vertical trace. And then we're just going to run them across there. That'll be 1, 2, 4, and 3. So once you get your points there, join them up. We can finish down these guys as well heavy. Of course, don't forget to finish your plan view out heavy. And I'll just throw a bit of colour on that so it's easier to see. So that's what our object looks like there when it's cut by that oblique plane. Now, the next thing we're going to be doing on the pictorial is to finish out that. And similar to the orthographic, they've shown us how they've gone and done that. Same thing. Run them in, your points in parallel to the horizontal trace. Then we're just going to bring them up vertically. We hit the vertical trace. We are going to run them back out. Point 1 there, they call, or 2. Sorry, yeah, 1 of those, 2, 4, and 3. And we'll just join them up. And join that guy up there. And I just put a bit of colour on that again. Now, the last thing we're asked to do there is in the orthographic, we're asked to find out over here the true length of the shortest diagonal. Okay, so they all look the exact same in plan view, but we can clearly see from the elevation 3 to 2 would be the shortest one. Okay, so I'll redraw that here. Now they want us to get the true length of that. So all we're going to do, almost similar to a generator in a cone, we can rotate that around. Until it's parallel with the XY line. And the reason we're doing that is because when we recreate this in elevation, which is the opposing view, that then must be a true length line. So we just swung it around as far as here, and now we go 2 there. That from 2 to 3 there is the true length of that line, short diagonal. Okay, moving on to question 2. This trophy here is based on a parabola. So I'm going to divide up each side into 4 equal sections. Now I've just printed out in an A4 paper. Maybe it works out for you on your A3 sheet if you have one perfectly. Well and good if it does. If it does not, you'll have to do this. And if you ever get confused about this, the vertex is there, but you could of course rotate your sheet and bring the lines all the way across and need them for mirroring later on. And we can just join them up like so. As I get the point here, here, and here. Next, I'm going to mirror them down. It ends up right on the black, actually, the black line. last thing we'll mirror them across here. Okay, should be the same as that. Now we can finish out our parabolic curve there. Now this will give us B and D, of course, and directly above B and D are P and Q, which is right here. P, Q, then across should be the other side there. So the last thing we've been asked to do in that is to draw the circle tangential there to the curves at points P and Q respectively. Okay, so what we're going to do there is we're going to join any one of them there from the focal point, and I'm going to run out a parallel line parallel there to the axis. Okay, and we're going to bisect that angle there. Now that'll give you the point then. Drop down your compass, set your radius, check it both right sides, and draw in your circle as required. And that's question 2, folks. Moving on to question 3. We've been asked here, draw the plane elevation, so showing these two planes ABC, ADE, draw the plane elevation of the line of intersection and determine the dihedral angle. Okay, so you can see there, it's running from here down to where B and C and D and E cross. Okay, so that's here. So we'll draw it in a plane there. I'm going to call that X just for clarification. And then we're going to bring up that'll come up to there. And that's our line of intersection now in elevation. Now, that's the line of intersection. Standard procedure then for getting the dihedral angle. We're going to look in at that to get its true length. Now that line there, we'll just bring 1 point from each plane, sorry. New view, 1 view back, 2 views back. Getting our heights from up here. There's only one height to get. That's A, X, D, B. And that's the true length. Okay. And now what we're going to do is we're going to look along this line now to see it as the point view. So set down your set squares there. Run on your lines out up here. We're now D. We're now B. And we have X2, Y2. Now, age-old question, where do I measure back from, sir? Well, it has to be the XY line that's parallel to the line of intersection. Only if you measure from here, both of them are the same distance, and that means you would end up with a point view. If you measure from anywhere else, you'll end up with a line. So that's XA. And we measure back B. And we measure back D then down here as well. So there's D there. And this will get your dihedral angle for you folks. Okay. And last thing there, determine the traces of the plane ADE. So that's like we're going to get a sheet of glass and we're going to leave it resting up there on that surface ADE. So the sheet of glass would have to touch the ground, of course, and it would touch along here. So that will get you your horizontal trace straight away. All we need is one other point then with a height, and we have A, of course. So bring this guy up parallel So that's parallel to that. Where it hits the XY line there, come up vertical. And then we're going to run out this guy here as well. Sorry, that guy slipped there now a moment ago. So that is him there. So that's a point there now on the vertical trace, and then we can just run this guy off like so. And that's question 3 finished for you. So last question coming up now. So this has to be one of their most favorite. They love asking these ones and ones to do with conics. So here we've 2 skew lines, AB and CD. So we've been asked for the shortest horizontal. Now always be aware that sometimes they can ask you for the shortest distance, but the shortest horizontal is different. Okay. So what we're going to do is we're going to create a plane that contains one line, and it has an edge that's parallel to the other line. Okay. And we must do the same thing, of course. If you slide AB out to hit D, you must do the same thing in plan view. Okay, and I'm going to call this point E up here. Basic orthographic tells us that E must be directly below there. Where it hits that line now, we'll find that first. Okay. So that's our plane set up in both views. Now, CE in plan view is a true length line, because if he's parallel to the XY line in that view, in the opposite view, he must be a true length line. So we're going to look along him, and this is going to let us see both lines as parallel. Okay. So set up your set squares there. And we'll run on that line. And B. I'm going to run on A there as well now. And we'll set up our X1, Y1 as close as we can. Of course, 2 views back, new view, 1 view, 2 views back. So we're getting our heights here from elevation. So I'm just going to join these in quickly there. Now I'm just going to measure these off. 33. Sorry, I just measure off this now. So I'm just going to measure them off there with the ruler. D. C is going to be this one here. C, B, C. Now perhaps a slight cheat, but what I often do here at this stage is to make sure they're absolutely parallel, just in case you had a bit of human error there, and they wouldn't be if you're measuring it off. I get 3 of them, and then I slide it over, and I make that guy there parallel to this guy, which he should have been anyways. So that is the way I do find my last point. Okay. Now the difference about the shortest horizontal, if this was just the shortest distance, you'd look in now perpendicular at these lines, but shortest horizontal, we must look in along here. Okay. So we're going to look in along that X1, Y1 line. Okay. Now run up all your points there. Name must be on this one. Set up our X2, Y2 line. There's only 2 kinds of these. It's either the shortest distance or shortest horizontal. And now, so here we are, new view, 1 view back, 2 views back. So you're measuring from here backwards, okay? So I'm just going to measure them off there with my ruler, okay? Or set square, sorry. 2, excuse me, C there. Measure back here, 35. and it'll differ how far you put your XY line back, okay? So 10, 12, 13, B is 13, 13 there, B is 13, and A is the last one there. So let's put down that there, and we have 38, 37, 37 there, okay, A. So then we just join them up again then, A to B, C to D, and now where we find them, where they crisscross here, okay, that's the point we're looking to bring back, okay? So we're just going to run them back through the views, parallel to our projection lines, of course. So there he appears there in that first auxiliary, and then we're going to bring him back up here, again parallel to the projection views that created that auxiliary. So there he's hitting AB, and here he's hitting CD. Okay, we'll recreate him there. And you'll notice the way the line is parallel to the X1, Y1 here. So when he goes up here, he has to be horizontal. He's the shortest horizontal distance. So 2 views back, he has to be parallel to the ground line up here as well. Okay. You can run them up. You just run up one side because if you want, run up the second one if you want to, but he has to be a shortest horizontal distance. And that is the shortest horizontal distance there got for you, okay? So just run it back to the views, bring them up there, and that's the shortest horizontal distance. Now the last part of that question was saying, determine and indicate in degrees the true angle between the horizontal plane, or the horizontal line, sorry, and the vertical plane, okay? So you can find out that there, if you just run in this guy into here, and it does say to determine and indicate in degrees, okay? So throw down your protractor there. Might have to extend this a bit to read that. Put down your protractor there. Read him off there. So he's coming off on mine at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So I'm making him coming out there. On my drawing, he's working out there at 45. Okay. So it could vary a degree or two with human error on yours. So that's it, folks. Hope you found that useful. More videos to come. Stay safe. Take care.